Example number 8, finding an equation of a line that models data. So let's check this out here. So the total sales of digital cameras in the United States in millions of dollars are shown on the graph, where the year 2003 corresponds to x equals 0. All right, so we have the years right here. So x equals 0 meaning this is 2003 right here. And then this is 04, 05, 06, and so forth. And this is the millions of dollars in which the sales have been for, per year. So digital camera sales. So in the year 2003, it was at $3,921 million. In the year 2004, somewhere between 4,000 and 6,000 million. I mean, these are decimals now. So, okay. So what we want to do here is we want to use the order pairs from the graph to write an equation that models the data. And what does the slope tell us about the context of the problem here? So we do know 2 points here. They give us what happens in the year 2003 is the 3,921 million. And the year 2006, again, the 3 now is 2006, we have $7,805 million. So let's first do the first part, which is find the equation of this line that would model the data. And basically, again, we're going to use what we did last problem. We have 2 points. Find the equation of a line given 2 points. All right. So we want to write our line so it's y equals mx plus b. Well, what's really nice is that we already know what b is. B is right here, right? 392 million. So y equals mx plus 392 million. I'm not gonna put all the zeros here, but we this is in millions here. Okay. And this is really important here because we only have to find the m and then we're done. So let's go ahead and find the m. So I'm going to subtract my y values. So 7805 minus 3921 all over 3 minus 0. So that's just simply 3884 all over 3. And if you divide that as a decimal, which actually we want right here, this is going to, so that means we have some context so we can answer the rest of part A. We have 1294.67, and that's our slope. So for part A, our equation is y equals 1294.67x plus our y-intercept, which is 3921. Okay, again, this is my slope and this is my y-intercept. So what does the slope tell us about the context of the problem? So what's the relevance? What's the real world application of 1294.67? Okay, so this is in millions. This is what it means. This means every year, so from year 2003 to 2004, from 2004 to 2005, and from 2005 to 2006. So every year, the cost of digital cameras have risen on average $1,294.67 million. Again, this is average. This is very important here. Average. We took 2 points, right? And we found its slope. That's an average because we're not accounting for these guys right here. Yeah, they're off by a little bit, but that's what the whole purpose of a linear model is, that we're trying to find a line that kind of fits it. It's not going to fit perfectly because lines are going to be all squiggly and all that kind of stuff here. So it's kind of like the best line that we can create right now. And this slope tells us the average every year the price of digital camera sales. So that's what you would write right there as a sentence when it asks that in part A. Okay? What about part B? Now, use the equation from part A to approximate the sales of digital cameras in the United States in 2007, which is really nice now. So now we have a linear equation. Can we predict something in the future? And we can, right? So if 3 on the x-axis is 2006, then a 4 would mean that's the year 2007. And again, these are the x values, right? So if I plug in x for 4, that's going to give me my approximation of 2007. So that's what I'm going to do now. I'm going to substitute x with 4 because that would give me my year 2007. Okay, and doing all that calculation, we would get 9099.67. Again, make sure you have the context of a million, because there's millions of dollars here. So approximately, we should have about $9,099.67 million in digital camera sales in the year 2007.